mark means? Not parallel. Yeah, but like, what about them? They're congruent. Okay, so if this was 5, this would also be 5. So basically, this piece matches this piece. Don't highlight that. This piece matches this piece. This piece matches this piece. They're not all the same. Okay. What we are going to add is a part that does not have the tick marks, but is also congruent. So BM is congruent to AM and is congruent to CM. So the lines that go from the vertex to the center, the vertex to the center, vertex to the center, those are congruent to each other. So we are going to add not 1 tick mark, not 2 tick marks, not 3 tick marks. We're actually going to take our pencil and we're going to do 4 tick marks on these. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. I can't use 1 tick mark because then it'd be the same as the 1. Can't use 2 because it'd be the same as 2. You know. Okay, so for this, circumcenters are created by what we did on Monday. On Monday, we did perpendicular bisectors. So it split the triangle in half and then it made the base congruent. And that's when the sides were congruent. And we were like, this is easy. Everything's congruent. So this is created by perpendicular bisectors. Perpendicular. Hopefully I spelled that right. These are the only parts that do not have congruent pieces. So they are literally the only segments that don't have little dashes. So one of the perpendicular bisectors, if I like kind of like cover this up and cover this up, that's like an isosceles triangle, right? The line in the middle is the perpendicular bisector. It's making it 90 degrees and it's splitting this bottom piece in half. So we're going to say MZ. MZ is one of the perpendicular bisectors. Can anybody tell me one of the other perpendicular bisectors? Tell me. Yeah. Well, XM. Oh, yeah. Because we already wrote MZ. ZM, MZ is same thing. So the other perpendicular bisector, like you said, is XM. And then the last one is MY. So these that don't have markings are the perpendicular bisectors. So XM, MY. And obviously you could write this backwards as well. So like the letters backwards. So the important facts about a circumcenter is that the circumcenter is equidistant. So take your colored pencil that you decided to use and highlight this word. Does anybody know what equidistant means? Equal distance. Good. So that's why we highlighted that. Oh no, what happened? Pause. I think this decided to restart. What's happening? Hold on, it's got to think. Oh, there we go. Okay. La, 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 la. So it's equidistant from each of the, like it's like multiple vertexes, which is like vertices. So we're going to say vertex though. So the vertex is the corner of the triangle. So we are going to write out the parts that are congruent. So we're going to say AM. A is the vertex. It goes to the center M. That is congruent to CM because it's a vertex to the center. What's the last line? Which one? BM. So that's all we're doing today is circumcenter. And then we will take this back out tomorrow and we will do incenter. So we're done with that paper for now. So don't lose your paper. Let's go to this one. So we're basically going to review exactly what we just talked about. So circumcenter is formed by the perpendicular bisectors. Next week, we're going to be constructing these with our compasses. When a perpendicular bisector meet and all the different sides of perpendicular bisector, perpendicular bisector, perpendicular bisector, where they meet is the circumcenter. The circumcenter is always equidistant from the vertices or the vertexes. So vertices. So this is a vertice B, A is a vertice, C is a vertice. And then in the diagram, we're going to label all these parts. So the perpendicular bisectors, this picture is a little different. The first perpendicular bisector is PF. PF is here. What's another perpendicular bisector in this picture? BP. What's another one? PE. Nice. The circumcenter is the point where they meet. At what point is that? B. Point B. Yeah. Yeah. And then we're going to list all the congruent segments. Now there's a lot going on in this picture, so this can be a minute, but we're going to start with the single dash. So I'm going to say BD is congruent to what? What else? DA. Let's do the one with 2 dashes now. So that's the base. So if I say AF, what is that congruent to?
FC.
FC. Once again, if you're thinking the letters can be backwards, they can be. It's not a big deal. The last side is over here. So if I say BE, BC, now there's something in this picture that's congruent that is not with the tick marks. We have to add the tick marks. Yeah. What? EC. Yeah. EC. BE, EC. My bad. I made my E into a B. E, not an E. Okay. The next part is on the inside. Yes. So AP is congruent to, what did you say? Not PE. BP, which is also congruent to what? CP. And this is the part that we are going to mark in the picture because it's not marked right now. This part, if it goes from the vertice to the center, it is the same length. So we're going to highlight it with a colored pencil. These are all the same length, even though it is not marked. So we have our 1 tick mark, 2 tick mark, 3 tick marks. So how many is this one going to have? 4. Okay. So using all of this knowledge that we just found in our brains, we are going to move around numbers because it's like a puzzle. Love me some puzzles. So anybody's brain big enough? Where can 19 move to? Yes, because it can go directly next to it because it's like a midpoint splitting it in half. If this whole thing's 34, each piece, wow, she was fast, 17. On the inside, you have the altitude, which is like the height. You have the bisector, but then you also have the one that's going from the vertice inside. So can I move the 15 or can I move the 21? The 21. So the 21, we're going to highlight it. If it goes from the corner to the center, corner to the center, corner to the center, those are congruent. So we're going to highlight it and we're going to move 21 around. 21 can go here. 21 can go here. 15 cannot be moved. If you look at those pieces, those leftover pieces, the perpendicular parts, and my geometry's picture, so let's use a little common sense. This is 15. That is not the same as this. You can tell with your eyeballs, this is smaller. It does not match, okay? So take a second, see if you can fill in some stuff. No, like you're writing the number. Like TU is how much?
Okay.
So how much is T? 38. So see how much you can fill in. Then you run no problem. You're like, what other number can I move? You can't move any other numbers. How much is Y, the VY? 17. How much is UZ? 21. And then you're like, this little guy.
17.
Nope. No. Okay. You can't, that's not a number that's given. So you have to do something mathematically. Who's got the big brain? Nope. Figure out how to find that missing piece.
Oh, wait, 21 plus B2, wait, no. 21 is C and then U2, A2.
Do you know what that's called?
Pythagorean.
Yes, Pythagoras, he's back. Back again. Okay, so technically all of these, look, those little squares, they're perpendicular. So they're 90 degrees. So all of these are technically right triangles. Oh, so we're going to color that guy in. We're going to color in this little triangle because we got to find WV. So I'm going to use the Pythagorean theorem to find the missing piece of my right triangle. This is the part of the year where everything starts combining. Everything comes together and we're like, I almost forgot about that guy. 21 is C because if you turn your paper sideways, then you can really see it's like a right triangle. So 21 is your hypotenuse. 15 is your altitude, which is your height. So like an airplane altitude, how high you're going. So we need to find the base, which is the bottom. So that's either A or B. It doesn't technically matter. But your formula is A squared plus B squared equals C squared. So C is the only one that matters. C has to be 21. So take a second. You're going to plug in your numbers. You're going to square them. Square 15, square 21. You have to solve for A. So this is where you subtract both sides. So you have to isolate A squared. No. Yeah. Yes, they're decimals. The Pythagorean theorem, we usually get decimals. Sometimes it'll round nicely to like a whole number, but we're going to round to the nearest tenth, which is 1 decimal place. So 15 squared.
It's 225. Ryan,
Yeah. We use. Okay, 15 squared is how much? 3, no. 225.
Yeah, that's what I said.
Oh, I thought you said 325. This is like 441. This is A squared. You should be subtracting 225, 225. Realistically, you can combine, like, you can like condense steps if you like understand what you're doing next. 216. When you square root it, you get craziness. 216 squared, square rooted, is 14.69. So we're going to do the first decimal place. So this is going to be 14.7 because the 9 is going to run the 6 up to the 7. So 14.7. So put it on your picture. When you find a piece of this picture, you need to move it around wherever it can go. So in this case, 14.7 can go next to it because they're congruent. So how much total is TV? 29.4 because it's adding them together. Okay, number 2, take a second, move the numbers around that you have. It's a puzzle. With the numbers, I would color in like some vertices from the vertex in, like shape with all 3 of those lines we match. But you have to find each. There's no numbers here, so it's easy to triangle, but you have this one, this one. 13 is my hypotenuse here. So your 13 is your hypotenuse. It's one of your colored lines. So you can move 13 around to all of those vertice lines. If it goes to the vertex, you can move it around. You cannot move the 3. So 3, and if you like have common sense, sort of, kind of, you look at the 3 is, you can't move that, but you can move it. So 13 can be on my pink line. So 13 can go here. 13 can go here. 7 can go here. How much is each one of these pieces? Well, because you cut it in half. So how much is GD? 12. How much is BC? Where the heck is BC? Oh yeah, BC is 14 because it's the whole thing. E to H does not have a number. So right triangle. Now, these triangles, if you think about it, there's two triangles, but they're both the same because you have a 13, 13, you have a 7, 7. So it doesn't matter if you color in this one or this one, technically. So I'm just gonna I'm gonna color in the top one, and then we're gonna do the Pythagorean theorem.
13, 7.
Yep.
Squared plus.
If you turn your paper, it kind of helps your eyes. The base is 7. The hypotenuse is 13. So 13 should be my C. And it doesn't matter if you put your 7 technically as your height on your little picture because your picture is just there to help you. So you're doing A squared plus B squared equals C squared. So square your numbers, subtract it, square root it. Whatever you get, put it on your picture. Might help you in the next step. Whatever you get should go back in your picture. Huh? Yeah. Yeah, because it's like it like rounds like 9, 5 or something. So then the 5 rounds the 9 to a 10, and the 10 goes up to an 11. So when you take the square root of 120, you should get 10.955. 5 makes the 9 go up, 9 makes the 1 go up. So instead of 10, it's 11.
E square root on the calculator.
So remember, we press 120 and then we shift and then the x squared.
Oh, yeah, then the square root. Yeah.
Yeah. Because it's the opposite of squaring something.
Yeah.
So 11 can go on my picture. 11 is here. Can I move the 11 anywhere else? No, I cannot because it's an altitude, so it doesn't technically move. But EH is 11. How much is H to D? 13. How much is C to H? 13. So try number 3. You're going to move around what you can. If it's an altitude, meaning a height inside the triangle, you cannot move it. You can only move the vertex and I'll move around technically 2 numbers in this picture. The inside, if you look, I think it gives you 2 numbers inside, but none of them are like the diagonal. None of them are the hypotenuse. 14 is the height. No. You can't move that. 23 is the height. You cannot move that. So you can only move 31 and you can only move 30. That means once you get going, you're going to have to use the Pythagorean theorem. Right. In your triangle, you should color in. So 31 can be here. 30 can be here. How much is GI? 60. How much is MH? Do we know? What? Nope. M to H is this. Ooh, I don't know it. So this is where I'm going to have to color in a triangle. And this is where it's kind of important where you color in your triangle too. Because you have this one and you have this one. Does this bottom one have enough numbers to find the hypotenuse? No. So I'm not going to use this one. Use the one with more numbers. So I'm going to use this one. I'm going to shade it in. Let's define MH. The base is 31. It's just upside down. The height is 14. So you are finding C this time. So it's the same Pythagorean theorem, but the problem is not a subtraction problem. You're adding them, you're squaring them, you're adding them, and then you're just square rooting that. When you get that number, That's the hypotenuse to all of the little triangles. So you can put that number in 3 different locations on your picture.
How do you think the Pythagorean theorem is? When you do,
Yeah, you do twice.
when
On the back, we're gonna skip one of them. We're gonna square root it. Ooh, this one's nice. Yeah. Oh, perfect. So it's 34.01, so we're just gonna say 34. Yep. So 34 can be all of the pink lines, so make sure you move it around. So now that I have 34, I can move to the next thing, which is IK. And you're like, what the heck kind of nonsense is this? If you want to exchange colored pencils with a neighbor, because we have to do another triangle. Because we don't have this number, we don't have this number. We have 34 and we have 23. So we can shade in this triangle. But this is where if you did not move your 34 around, you wouldn't have enough information. So 34 had to move to all the different spots. Once you know something, move it around. So I'm going to make another triangle. Hypotenuse is 34. Height is 23. We're going to find the bottom. That's either A or B of the Pythagorean theorem. It doesn't matter which one you want to make it. So this is going back to like a subtraction Pythagorean theorem. So much math. This is where geometry starts getting a little cray-cray. With all of the tools. You know. Subtract. 31 is the least. So you can because in the second line, so square your numbers. So 23 squared gets something big. Does anybody know what 23 squared is? 29, 34 squared. Okay, and then this is where we have to minus 529 to both sides. 627. And then we have to square root, so how much is A? 25. So IK is 25. When you find it, put it in your picture because it helps you for the next step. So then HI is how much? 50. And then MG is 34. How do we feel today? It's not bad, right? It's not bad. Yeah, it's a little, you're tired. It's first week back. First week back, which is feels like it's been a long time since we took back, but really it's not like it's been like a long 4 years of my life.
When we start doing this independently, we will be the biggest this history.
Yeah, it was super easy. Okay, we're gonna do one more on the back because they're not all super crazy like this. Okay, just so you know. If you have just numbers, then it's like a big puzzle. Okay. If we're gonna go to the back, we're gonna cross out number 10. Let's set up number 9. So number 9 says find DP. So now if you notice, you have equations and you're like, great. So we're throwing equations on today. It's actually, I think, easier, less like puzzly, more straight to it. So I have to find DP. So why don't we color that? Gotta find DP. Anybody have an idea of what I could do first?
the ones that
Good. Okay, so these ones, let's color our original lines. So these ones are little angle lines. These ones connect. So all of those are 39. So all my pink lines are 39. So I can move 39 around. 39, 39. I still have to find my green line. They gave me an equation and stuff. What should I do with these two things? equal them to 39? No. Yes. They're the same because it's a perpendicular bisector. It's splitting the bottom of the triangle. It's just turned in half. So they are equal. So this goes back to like basic equations. So take a second, solve for x, and then you're going to plug it back into your x equations. So add your 52 to get rid of your negative. Once you find x, plug it in. Plug it in, plug it in. What do we get for x?
11.
Good. Now if I plug it in, because it's a 2 times 11 is 22 plus this 36. Okay, this is 36, right? This is 36 too. Yeah. Okay, how do I find the green line? Pythagorean theorem. So we're gonna take our little right triangle, and you can do the top one or the bottom one, it doesn't matter. So this one we're gonna do our little bloop 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 bloop. The hypotenuse is how much? 39. The base is 36. So your Pythagorean theorem should look like a squared plus 36 squared equals 39 squared. So once you solve your Pythagorean theorem, that will give you the answer to the altitude. And that is as hard as it gets. Okay. So keep going. Square them, subtract them, and then you guys can skip number 10 and then start working through. Once you finish number 9, start working on the back. You're going to take a picture of it and put it on Canvas when you're done with the back. Let me know.